Today, we are jumping straight into a really fascinating paper for late 2025. It's called Professional Software Developers Don't Vibe, They Control, AI Agent Use for Coding in 2025.
And it's such a critical reality check. They looked at 112 seasoned developers, people with real experience working on production code. We can basically boil their findings down to four key takeaways right at the top.
Okay, what's the first one?
First, the core idea. These experienced pros completely reject what you might call vibe coding, just trusting the AI to do its thing. Their entire strategy is built around strict human control and constant supervision.
So, no blind trust. What's motivating them then?
Well, that's the second point. It's a mix. They're definitely in it for the huge productivity gains that was mentioned over and over, but at the same time, they're obsessed with software quality. Correctness and readability are non-negotiable.
And the third takeaway is how they apply that control.
Exactly. It's all about detailed planning up front, very specific prompting, and this is the kicker, implementing changes in tiny, verified chunks. On average, they let the agent run for just 2.1 steps before they step back in.
Wow, just 2 steps. So what's the final point?
Suitability. These agents are fantastic for boilerplate, scaffolding, and simple repetitive tasks. But for complex business logic or anything high stakes, they're just not trusted. That tension between speed and control is really the whole story.
Okay, let's dig into that experienced developer mindset a bit more because it feels like that's the key to everything here. This isn't about students or hobbyists.
Not at all. These are professionals, and the productivity numbers are they're undeniable. The paper makes it so clear that once you get used to this, you can't go back.
I mean, you have quotes in here like, there's no way I'll ever go back to coding by hand.
Right. Or another developer who estimated that their productivity had increased tenfold. A tenfold increase. That's not just a small improvement, it's a fundamental shift.
But that's what's so interesting. If you're seeing a tenfold gain, why is the immediate reaction from so many of them to, pump the brakes and worry about quality?
Because they've seen what happens when you don't. They know what technical debt looks like, and they're terrified of an AI creating it at scale.
So they're worried the agent is just optimizing for a quick solution, not a good one.
Precisely. One developer said they worry agents produce messy and unnecessarily long code. So the human has to act as this quality filter, making sure the output is actually maintainable.
Which brings us back to correctness and readability. Correctness, I get. Obviously, the code has to work. But why is readability such a huge deal for them?
Because production code lives on for years. It's not just about you, it's about the next person who has to debug or extend that code. If an agent writes something that works but is impossible for a human to understand, you've just created a future nightmare.
So this is why they are so against vibe coding. Can you just define that for us quickly?
Yeah, the paper describes it as basically aiming for that flow state by letting the AI generate huge chunks of code with very little guidance and then not really reviewing it. Fine, for a weekend project you're going to throw away, maybe.
But for production software with real users and real money on the line, it's a non-starter.
A hard stop. And it's for a few key reasons. One, they value established software engineering principles that the AI just doesn't inherently get.
2, like you said, the stakes are way higher. This is production software.
3, and this one is really insightful, if you let the agent just run wild, you spend more time fixing its mistakes and guiding it back on track than you would have just being specific in the first place.
And the 4th reason is just expertise, right? The human knows the business, the domain, the quirks of the existing code base.
Exactly. The human has the why. The agent only has a statistical model of how. The developer has to be the pilot.
Okay, so if they're not vibing, they're controlling. Let's get into the mechanics of that. How does this control actually manifest in their day-to-day workflow?
It all starts with the design. Every single participant who was creating a new feature, they own the design plan. The human was always the architect.
So they might ask the agent for ideas, like a rough draft, but the final blueprint is human-made.
Absolutely. And that leads right into prompting. This isn't just, write me a function. They treat the prompt like a detailed spec sheet. The study found they were basically treating the AI like a really smart intern.
A smart kid that knows nothing about you in the outside world was the quote, I think.
That's the one.
Yeah.
And to make up for that lack of context, they just flood the prompt with information. Technical terms, UI details, references to other files, domain objects.
I saw that figure in the paper, one developer using 7 different types of context in a single prompt just to get the agent to do one small thing correctly.
And goes beyond that. They're also using what the paper calls user rules to enforce specific methodologies, like you must follow test-driven development. They're forcing the agent to work within their existing rigorous processes.
This level of detailed planning, it leads to what I thought was the most stunning finding in the entire paper, this piecewise implementation strategy.
This is the absolute core of the control not vibe thesis. You see these huge plans, right? Some of them are over 70 steps long.
70 steps. You'd think, okay, maybe they tell the agent, go do the first 10 steps.
You would think, but that's not what happens. The actual average number of steps they let the agent execute per prompt, it's just 2.1.
Let's just sit with that number. A mean of 2.1. That's just an incredible lack of trust.
It's a profound trust deficit.
Yeah.
A 70-step plan becomes this long, drawn-out conversation of 35 tiny interactions. One developer literally had to write, please do just step 1 now, to stop the agent from running ahead.
They're actively holding it back from creating a mess they'll have to clean up.
That's it, exactly. They're using it as a laborer that requires constant, and I mean constant, micromanagement.
So here's the question that number raises for me. When someone says they're getting a 10-fold productivity gain, but they're also micromanaging AI 2 steps at a time, are they really 10 times faster? Or are they just trading the work of typing for the work of, I don't know, hypervigilant steering?
That is a fantastic question.
Yeah.
It seems to be an optimization, not an elimination of work. They're shifting their cognitive load from the tedious part, the syntax, the boilerplate, to the high-level part, evaluation, correction, and planning.
Yeah.
It's a different kind of work and apparently a much more enjoyable one. But the human responsibility is still there 100%.
And what about after the code is generated? What are the other control strategies they're using?
Well, it's all the classic stuff. Systematic testing, rigorous version control so they can roll back if something goes wrong, and just reading the code line by line. Over 60 respondents said their core coding skills are more important than ever, not to write the code, but to evaluate what the agent wrote.
So the agent doesn't replace expertise, it actually makes your review skills even more critical.
It really does.
All right, let's pivot to suitability. Given all this control, where are agents actually a good fit and where do they just fall flat? The paper had some really clear data on this.
Yeah, the SU ratios, the suitable to unsuitable scores, they paint a very clear picture. And overall, the rating was pretty high. They definitely see the value. Agents are basically acceleration tools.
For the grunt work, right? Scaffolding, boilerplate, tedious and repetitive tasks, those all had almost perfect scores.
Exactly. And that extends to a lot of standard software engineering chores, things like writing tests, updating documentation, simple refactoring, and basic debugging. They're all great use cases.
It's also good for prototyping, it seems, where you just need something that works, even if it's a bit messy.
Right, for exploring ideas quickly. But then you get to the more controversial areas, like planning and architecture design.
And that's where the results get really mixed. High-level design had way more unsuitable ratings than suitable. What's the fear there?
It's a fear of the agent making poor architectural choices that you'll be stuck with for years. System design requires deep, proprietary knowledge about the business and the tech stack. And LLM just doesn't have that.
But on the other hand, some developers did find it useful in that area, just not as the architect.
Exactly,
Yeah.
as a collaborator. For brainstorming, one developer called it a full-time rubber ducking partner. It can suggest alternatives and help you see your own blind spots, so it can assist the design, but it can't own it.
And then there are the areas where suitability just completely plummets. Where does the agent just totally fall apart?
The second you introduce complexity or domain knowledge, things like core business logic, the scores are overwhelmingly negative. The really valuable, unique parts of the code base, that's still all human.
And it seems there's a deep distrust in the raw output itself. The idea of one-shotting code without checking it was just rejected outright.
Completely. The scores were something like 5 suitable to 23 unsuitable. The code always needs cleanup. It needs to be integrated, especially with older legacy code, which got a terrible score. The agent really struggles with the messy reality of an existing code base.
And I'm guessing for the really high-stakes stuff, it's a hard no.
A very hard no. Performance optimization, privacy-sensitive tasks, and, this is the big one, 0 respondents thought an agent could replace human expertise or decision-making.
Okay, so we've got this picture of developers in this constant state of vigilance, micromanaging every little step. But Did they actually enjoy this process? It sounds kind of exhausting.
You would think so, but they loved it. The average enjoyment rating was super high, a 5.11 out of 6,
Really? Why?
because it made coding fun again, to quote one person. It removes the drudgery. They get to focus on the interesting part, the architectural thinking, the problem solving, and let the agent handle the tedious typing. It actually reduces stress.
That reinforces this whole collaboration model, doesn't it? It's a tool, not a replacement.
It is. I think one developer just summed up the entire paper perfectly. He said, I do everything with assistance, but never let the agent be completely autonomous. I'm always reading the output and steering.
So what's the big takeaway for the future of software engineering then?
That AI assistance is here to stay, but it absolutely requires a strong human foundation. The danger is that without real expertise, the agent becomes a crutch. You end up with code that's a nightmare to maintain, as one person put it. It demands higher level skills, not lower ones.
This feels like a really solid snapshot of where we are in late 2025. This is the new baseline. Professionals have adopted these agents, and they can't imagine going back, but only because their expertise allows them to control the output.
Right. The human is the quality control layer that makes the whole thing work. It's a powerful partnership.
So the core finding from this deep dive really is that you get the most out of AI, not by trusting it, not with this vibe mindset, but through rigorous human control and planning. It's classic software engineering discipline applied to a new tool. But this leaves us with a really critical question for everyone out there building these AI models. We've seen that developers, even with these huge 70-step plans, only trust an agent to run for about 2 steps on its own. That 2.1 number reveals a huge gap between human intent and the agent's reliability. So the challenge for all of you is this. What are the specific advances needed, beyond just more parameters or more data, to get that number from 2 steps up to, say, 10 or even 20 reliable steps without compromising on correctness and security? Because until you can bridge that trust gap, the human is going to stay very firmly in the driver's seat.